Hey, yo, algebrainiacs! Welcome to the Johnson-Kendrow video hour.
But it's not an hour.
So don't you fret. All right, today is section 3.2, solving systems algebraically. Systems are when you have more than one equation together. We have three methods to solve it. First one is graphing, substitution, and then elimination. We already did the graphing, so we're going to jump right to substitution. Substitution, just as its name implies, is we're going to isolate something and sub it into the other equation. So here's the first step. We are going to choose a variable to get it alone. Now choose wisely, Grasshopper. You have to choose one that's easy. In this case, I think y is pretty easy to get alone because all we have to do is subtract x. So I have y equals, now I'm going to put my x first just because I'm used to doing that with lines. And then I'm going to take this because it's equal to y, and I'm going to put it in right there for y. So I get 2x minus 3 times negative x minus 12 equals 6.
I like how you use those parentheses.
Why, thank you. I do that so I remember to distribute the 3 to the whole thing that means y. This whole thing is y, not just the beginning. So, negative 3 distributes, so I get negative, actually 2 negatives make a plus, 3x. 2 more negatives make another plus, and then I get 6. Keep going, 5x. Now I want to subtract 36, so negative 30. Divide by 5. Getting out of the room here. Let me move it down so that I have x equals negative 6.
So you're done? You got a solution?
No, I'm not quite finished because remember, when 2 points cross, or 2 lines cross, it's at a point. So we need an xy point as our solution. We only have the x. So far I have this. So I need to take this and put it back in to either one, but remember, choose wisely, Grasshopper. We want to choose the one that's easiest. I think this one's easier because there's no big numbers in front of the x's and y's. So if I plug that x negative 6 in, I get this. Then I'm going to add 6 to both sides. So I get y equals negative 6. So that, my friends, is our solution.
Could we check that answer if we wanted?
Oh, you always can check. You just put them both back in and make sure the equations come out true. Then they work. All right, this one, nicely, look at that. It's already got one isolated.
You chose wisely, Grasshopper.
I am choosing very wisely. Okay, so all we have to do is put this in for the y up in this equation. So 4x plus 2 times 5x equals 7. 4x plus 10x. 14x equals 7. Divide by 14. So x is 1/2.
You mean we'll get fractions?
Yeah, fractions. Wish we could fire those fractions, but we can't. So we still have to put that back in. So 1/2 is 1/2 of the answer. Ha, ha. So let's put that back in right here or right here. Which would you rather do? Doesn't really matter. I'm going to go with this because there's less work involved. So I have y equals 5 times 1/2. Well, 5 times 1/2 is just 5 halves. So we're going to plug that in. And if you want, you can plug them both back in to check to make sure they work. All right. Our second way of doing this is solving systems by elimination. If we're going to eliminate one of the variables, we'll be able to solve for the other one. Okay, now, it works best if you have opposites. Okay, like 3x and negative 3x. And then the equations are in standard form. That's the ax plus by equals c. All right, so both equations in standard form, we're going to do that. Then looks like these are both in standard form already. It's got the x, the y, and the regular number. We're looking for opposite coefficients. I see two opposites right here, 3x and negative 3x. So now we're going to add each column. So I'm going to put a line underneath. This is 0. I like to just cross those off so I don't need them anymore. Y and negative 2y, we add those together, so I get negative y. And then negative 9 plus 12 is 3. So I'm not finished. I got to get the negative to the other side. So if you want to think of it as dividing by negative 1, that's the way to do it.
So we're done. We got an answer, right?
No, no, no. That's only half our answer. We've got the y part. We need the x part. So again, take the y and put them into either equation. I'm going to choose this top one. So 3x plus negative 3.
Ooh, I like your parentheses.
Thank you. Negative 9. That makes it kind of cozy, don't you think?
Yeah.
All right. So then we're going to add 3. So 3x equals negative 6, x equals negative 2. And there you go. That's where those two lines cross to get your answer. Okay, here's one. It's already in standard. However, I don't have any opposite variables or opposite coefficients.
So I can't just cross those x's out?
Because we're going to add. How do we add? 2 and 3 gives me 5. I need it to go away. I need to force this to become what we want. So what I'm going to do is I'm going to multiply this top row by 3 and this bottom row by negative 2. Now, look what happens. If I distribute that 3, I get 6x plus 12y equals negative 12. The next one, I get negative 6x minus 10y equals 6. See how these are opposite now? That's a good sign. Now I can add. I add them up, so these go away. I get 12 negative 10 is 2y. Negative 12 and 6 is negative 6. Divide. So y equals negative 3.
So we're done.
No, we're not done. So put the negative 3 back in. Let's go here. And I get 2x plus 4 times negative 3. And then multiply negative 12. Add 12. 2x equals 8. So x equals 4. All right. And also you can always check. If you want to put those back in, check in both equations, and it should come out true. All right.
Good job, Mrs. Kimbrough.
Why, thank you.
Okay, we have some special situations. And we've talked about those a little bit with graphing, but now I'm going to show you how they come up when we're doing substitution or elimination. So,
Good thing you're doing the special cases, because you're a special person.
thanks, Mrs. Kimbrough. I learned from the best. So, all right, these are both in standard form, and when I look, I see those opposites that she was talking about. I think they're ready to cancel out. So if I do addition, these cancel, I'm left with 0, but something weird happens. This also cancels.
Whoa.
I'm left with 0. And these cancel, I'm left with 0. So I have 0 equal to 0. There's no variables whatsoever.
Freaky.
So what you need to ask yourself is this true? Is 0 equal to 0?
Always.
Okay. That means that we have infinitely many solutions. That means we have exactly the same line. And remember, the word we used to say that was dependent system. I will accept infinitely many solutions. It means we have exactly the same line. If we were to graph it, it touches infinitely many times. There is one other possibility. So I'm going to do elimination again, add these. This cancels, I get my 0. But when we do the other side, I get 12. When I go to ask myself, is it true?
No way.
All right, if the answer is no, then you would have no solution. Remember, we called that an inconsistent system. Inconsistent system or no solutions. That means those lines are parallel, they never cross. All right, let's apply what we've learned to make some of our own systems. So I've got some hints for you for your word problems. Identify the variables, identify what your two equations are about, write the equation, solve the system. So let's get started with our first one. You are buying milkshakes for your friends because
I love milkshakes.
you're really nice. So
Chocolate.
okay. Small milkshakes cost $3 and large milkshakes cost $4.
I'll take a large, please.
Okay, we will buy a total of 6 milkshakes and we spend $22 total. How many of each size did you buy? I know we need a system because there are two things that I don't know. I don't know how many small and I don't know how many large. And I'm given two different equations, believe it or not. So the variables that we're going to represent here, let's let X be the small milkshakes and Y be the large for Mrs. Kendrow.
Woohoo!
Okay, next we want to decide what the equations are about. They're telling me some totals. They're telling me I have a total of 6 milkshakes and I spend a total of $22. So one equation is going to be about the total number and one equation is going to be about the total amount of money that I spent. Okay? So this total equation is kind of like a hidden equation because it doesn't tell us that how much we're spending on each or anything like that. We just need to decide how would you come up with the total amount. Well, you would take the number of smalls that you buy and you would take the number of larges that you buy and you would add them together. So my first equation is x plus y is equal to 6. And that will be your equation anytime you're referring to a total number of things. The second one's about the money. Remember, I spend $3 per, and we've talked about per a lot this trimester. $3 per small, so it's 3x, and $4 per large, so that's y, and I spent $22 total. It is up to you what method you want to use. I'm going to go back to what Mrs. Kendrow taught us about choosing wisely. If I wanted to get the y by itself in this top equation, all I would have to do is subtract x on both sides. I get y equals negative x plus 6. That will substitute for y into my other equation. So I'll set that up. 3x plus 4, and my whole y is represented by that new equation.
Nice parentheses.
Thank you. Equals 22. I need to distribute. That's why I need those parentheses. I get 3x minus 4x plus 24 is equal to 22. I'm going to simplify on this side. I've got negative x plus 24 equals 22. Subtract 24. I didn't leave us enough space, did I? Okay, negative x equals negative 2, therefore x equals 2. That's one answer. That's how many small milkshakes I got. So
You mean we're not done yet?
no, we're not done yet. We need to know small and large. But remember, if I bought 2 smalls, I need to know what y I would have to get a total of 6. So I'm solving the equation 2 plus y equals 6. Subtract my 2 and we get 4. The solution is 2 small and 4 large.
And one of those larges is for me, right?
That's right.
All right, nice job, Miss Johnson.
I love those
And
milkshakes.
Don't have too many though. Your cholesterol will skyrocket. Okay, you kids have a good evening. See you in class tomorrow. Ta-ta for now.